joining us live from NASA's Johnson Space Center in Houston, Texas. We're here today to discuss the upcoming spacewalk on Monday, April the 8th, in which two spacewalkers will continue the work that's been done over the past couple of weeks. On Monday, you can expect to see NASA astronaut Anne McClain step outside of the hatch for her second spacewalk, and she'll be joined by Canadian Space Agency astronaut David Saint-Jacques. These spacewalkers will continue the work on the space station's batteries. As you can see here in the room, we've got an example of the adapter plate, which we'll discuss a little bit more later, and they'll go into some other tasks. But first, let's meet our experts here with us today. First, we have Kenny Todd, with the Operations and Integration Manager for the International Space Station. Next is Rick Henfling, the Flight Director for this EVA. And additionally, we have John Mularski, who is the Spacewalk Lead for Monday. We're going to start out with some comments from each of these participants, but you can prepare your questions for a little bit later in the show. If you're on the phone, please press *1 to indicate that you have a question. And if you notice that your question has been answered, please press *2 to withdraw it. If you're following us online, feel free to use the hashtag AskNASA to submit your question. First, we'll start with Kenny.
Thanks, Leah. Well, good afternoon, everyone. It's great to be here. It's actually really good to have two of these three EVAs in our rearview mirror now. Completely successful. Crew did a fantastic job. We've got lithium-ion batteries up and running in channels 2A and 4A, which again was our goal from the beginning of this set of EVAs. Rick will talk to you about our third EVA and some other, I'll call them kitchen sink type tasks that we've been trying to get done for some time. And we're still making some changes to that EVA, and I'll talk to you a little bit about that. But from a battery perspective, the lithium ions are performing as designed up to this point, with the exception of one single battery that we're having some issue with on channel 4A. That was the first set of batteries that we put in here a couple of weeks ago. Two of the batteries on the channel 4A are working fine. One of them at this point looks to be failed, and we're not anticipating any type of repair action for that particular battery itself. We are, however, we're undertaking a set of robotics and EVA activities to allow us to reinstall two of the nickel hydrogen batteries back in to that slot in that particular string where that lithium-ion battery is currently failed. So during the second of these three EVAs, we put a small task in there to go back to the work site on channel 4A and remove a cable. Once we removed that cable, that allowed us to be able to press ahead with some robotics activities, which are underway this week, actually starting and taking place today and through the rest of the week, to essentially remove the lithium-ion battery that we think has failed and reinstall two of the other nickel hydrogen batteries. So the way the sequence is going to go, in addition to the lithium-ion battery, it looks like that particular string also has another power box failure. It's called a BCDU, a battery charge discharge unit, that interfaces directly with the lithium-ion battery. So we're gonna replace both the lithium-ion battery as well as the BCDU, and those robotic activities are underway as we speak here. But again, that all got kicked off with removing this cable on the second EVA that was installed during the first EVA. So we'll press ahead. We'll install the BCDU today and get that removed and get the new one in place. Later in the week, we're going to reinstall the first nickel hydrogen battery in that location where the lithium ion was, and then Rick and his team are going to go out and do an EVA, take an adapter plate that's in one of the other nickel hydrogen slots and move that adapter plate, freeing that location up, and then after the EVA, we'll take the second nickel hydrogen battery and drop it into that spot. So when you look at channel 4A at its conclusion, it'll have one of the strings will have two of the strings will have a lithium-ion battery, and then the third string will have two nickel hydrogens. So it'll be a mixed configuration. We anticipate that we can run that configuration for quite some time and get us back to our nominal power capability on Channel 4A. So we feel really good about where we're going to end up on the backside of these EVAs and robotics activities, and so we're in the process of trying to carry all that out over the next week or 7 or 8 days, and we'll let that work get done. As for the failed components, the BCDU, at this time we're planning on trying to bring it home on SpaceX 17 if we can. That would be our goal. We've got a lot of other things that we're trying to bring home on that particular Dragon, but we're going to do everything we can to get it home here in the spring. It's the first failure of a BCDU, so we're obviously interested in trying to understand what happened to it. We have a lot of these particular boxes on station. They've been extremely robust and have served the program for a very long time. So, you know, the fact that we had one failed is not a total surprise given the amount of time that they've been in use. But again, just trying to understand what might have happened is going to be our next goal. As far as the lithium ion goes, our best guess right now is to put it on the pallet that came up on, and at some point here in the future we'll dispose of the pallet with the batteries that are on there, and we won't be returning the lithium ion battery itself. We will in the future fly up an additional lithium ion battery and install it in that slot, although at this point I can't tell you if it's 3 months away or 6 months away. That's all still very much a part of the discussion. So we'll have to continue to look at all the options to try to get a replacement lithium ion battery up there. They do exist here on the ground, and so it's just a matter of us getting one ready to fly and finding a slot for it on a vehicle coming up to station. So we'll go have those discussions here in the near term and start to target a recovery for that particular location. Other than that, the crew is doing fantastic on board. We do want to go ahead and get this third EVA done shortly after we finish this triple EVA set. We'll be getting ready for the Northrop Grumman flight, followed a week later by SpaceX Dragon. So by the end of April, we're hoping to have two new visiting vehicles on station, and so we're right in the middle of the throes of it now. But it's been a pretty exciting month so far, and it's still early. So we're looking forward to the next 3 or 4 weeks, and it's a pretty exciting time. So with that, I'll turn it over to Rick, and he can talk about the specifics of what we're going to do on Monday.
Okay, good afternoon, everyone. I'm Rick Henfling, the lead flight director for the Trust Jumpers EVA. That's US Spacewalk number 54. Before we get out and conduct our spacewalk on Monday, we have a few robotic preparation activities that Kenny had mentioned. In summary, we have the removal and replacement of that battery charge discharge unit. And then we also have an activity to remove the failed lithium-ion battery from the integrated electronics assembly. We're going to take it over to the pallet, which was the component that brought up all the batteries on the HTV-7 mission. Once those activities are complete, we will be in a good configuration to have the spacewalkers take an adapter plate that was originally intended for use with the failed lithium-ion battery, and we're going to move it over and stack it on top of another adapter plate, which is currently in use. And the engineers who developed these adapter plates did a great job in providing a design that allows these plates to stack on top of one another for just this type of situation. And this is a task that we didn't originally plan to do on this spacewalk, but as the third EVA in a series of 3, we understood that it was certainly a possibility that we would need to react to some of the issues that were encountered in real time. And so the team has done a tremendous job to be flexible in the planning of this spacewalk, and we'll be ready to go on Monday. As for the crew, preparations are going well. The tool configuration is being done on board today. We have a little bit more tool configuration later in the week. The suits are behaving extraordinarily well. Typically, when you have a series of EVAs, there's a number of suit considerations and items of interest to make sure that we run to ground. But we are doing really well from a suit perspective, and the 2 suits we're going to send outside for use by Anne and David are in great shape. Tomorrow we have a study session to review the procedures, and then if the crew has any questions, we'll have an opportunity to have a conversation with them to clarify any questions they may have. And everything else is proceeding well with the rest of the EVA preparation activities for conducting operations on Monday. At this point, John can discuss the specifics of the tasks that we're going to conduct during EVA 54.
All right, thanks, Rick. I'm John Mularski, the Lead Spacewalk Officer for this EVA. As Rick mentioned and Kenny mentioned, we're adding an adapter plate relocate. So the batteries themselves are robotically compatible, but the adapter plates were designed only to interface with EVA crew members. So this is designed, a battery can actually interface right on top of this for storage locations. So the robotics folks will take those batteries off, and we will have the crew actually, they have a hex driver that inserts down into the socket here and actually unscrews this adapter plate, and they will pick it up and relocate and stack it with another adapter plate. They'll also have to restore this cable to its original launch configuration. It was originally linked to the neighboring lithium-ion battery, and then it will go to the stowage configuration. Once the crew has stacked the adapter plate, they'll have cleared the way for the robotics folks to install that nickel hydrogen battery back in place. And then we will pick up with our normally scheduled activities, which we've got a video and animation to show the rest of the activities that are scheduled for this EVA.
US EVA 54 will be conducted by Anne McLean, EV1, in the red stripes, and David Saint-Jacques, EV2. EV1 will lead out of the airlock to the nadir side of the US lab and temp stow the bag. EV2 will be going over the top of the lab. They will meet up at the same work site, but they'll take different paths to deconflict their safety tethers. After going over the top of the lab, EV2 will temp stow the bag on the zenith side of the US laboratory. From here, both will converge on the port side, forward end of the US lab, where they've got a MMOD or micrometeoroid debris shield that they'll release. The crew will work to release that shield and the underlying insulation, then connect the cables underneath. They'll set up their bag with that cable and work to clear the site. They'll remove an electrical connector which will allow them to access that shield, as well as removing a translation aid, known as a gap spanner. Once that's complete, they can access that shield and get underneath to connect an Ethernet cable that will be utilized to route to various parts of the truss for future wireless Ethernet connections. This will spread wireless Ethernet connectivity to payloads on the outside of the International Space Station. EV1 will disconnect a cable, then take the new cable from EV2 and hook it up under the shield. Then they'll replace all the hardware that they previously removed. From there, EV1 will transition to the Node 1 nadir worksite and remove another MMOD shield and route cables for a power upgrade of the space station. These jumpers will be utilized in conjunction with the other ones that EV2 will be routing. This will allow the station to react to external power failures by reconnecting IVA jumpers inside the space station, as opposed to having to spend an EVA to reconfigure the power system. Now, EV2 will work from the zenith side of Node 1, directly above EV1. EV2 has a longer set of jumpers that will run from the forward side of Node 1 routing into the S0 truss through the MLI, where he will temp stow those for EV1 to pick up later. EV2 will wire tie them along handrails to keep them out of the way of any future EVAs. Once finished routing that cable, EV2 will come down and help EV1 secure the micrometeoroid orbital debris shield over the Node 1 nadir worksite. From there, the crew will transition back to the airlock to pick up bags for the next task. EV1 will be heading up to the S0 truss to pick the cable that EV2 had previously left. This is the one just installed through the MLI on the aft side of the truss. EV1 will enter the bay and continue routing it inside of the truss, separating the blue and red cables. The blue cable will transition to the next bay over to the right, while the red cable will be temp stowed on a handrail for installation at a future time. Once those cables are connected, EV1 will exit the truss bay, enter the adjoining bay, and complete the routing of the blue cable. With the connection of the blue cable, that completes one leg of that redundant power path that will enable the Space Station Canadarm2 to utilize redundant power supplies, if needed, in the event of a power failure. At the same time, EV1 is connecting those cables, EV2 will have picked up what is known as the Bartolomeo Training Slip-Off Protection and head to the front side of the European Space Agency's Columbus module. These are plugs that are going on into the end of the trunnions. These are the trunnions that were used to hold the module in the Space Shuttle payload bay for its ascent. These plugs will widen the end of the trunnions to help in the installation of the Bartolomeo platform that will be launched by ESA at a later date. EV2 has installed one and is moving to the outboard worksite to install the second slip-off protection.
Thank you very much to Rick, Kenny, and John for joining us and telling us more about the EVA, the spacewalk. We are going to now open the floor for questions. So we have media in the room, and we may also have some on the phone line. Just a reminder, if you have a question, press *1 to queue it up. And if you hear that question answered before you get the chance to ask it, press *2 to remove it. We're also online, and you can ask your questions using the hashtag #AskNASA. So we'll start. Does anybody in the room have any questions? Okay. And don't forget to state your name and affiliation before answering your question.
Sure. Hi, Robert Perlman with CollectSpace.com. It was mentioned that the BCTU, this was the first failure of its type, and that you want to bring it down to look at to see why it failed. Do you have any theories as to what the failure might have been?
Not at this point. We really don't. We're not even hazarding a guess at this point. That's why it's important to us to get inside the box, and usually it'll have some signature once we get in there. But no, we basically just saw the output not acting the way we want. So we feel pretty strongly it's failed, and we'll get confirmation when we put the new one in here later this afternoon and start trying to do some work with it. But no indications at this point.
And it was mentioned that the part of the work for this EVA is to provide a redundant power source for the Canadarm2. Just to clarify, so the ARM has not had a backup power source until this point, and was there an event that triggered this idea of why it needs to be added now?
So the ARM does have redundant power sources, and we have increased the capability and the tasks that we are comfortable performing with that ARM. And so if one of the power sources that supplies power to the ARM fails, we now have the opportunity to do a remove and replace using the ARM itself. However, we wouldn't want to operate the ARM in a zero fault tolerant configuration so that we would be susceptible to a failure that would leave us in an ARM configuration that would be unsatisfactory. So by having this redundant power source to protect us in the event of a failure, we can now still perform robotic removal and replacement of various devices on the external part of the station without having to send the crew members on another spacewalk, because there's risks associated with the spacewalk anytime we go outside, and if we can reduce the opportunities of exposing the crew members to those risks, it's beneficial to the ISS program.
Thank you. I'm Mark Carreau with Aviation Week and Space Technology, and I have a couple of questions. My first one is, are the lithium-ion and nickel-hydrogen batteries electrically compatible to your satisfaction working close together? I know you've had them on different sides of the solar array, but I just wonder if the proximity adds any sort of concern.
Not. Are they compatible? Yes. When you take the strings and you look in there, there's a BCDU, if you will, that's interfacing with each string. So there's 3 BCDUs and there's three essential battery sets on there. So 2 of them are going to be hydrogen. They're going to be working with its own BCDU. Each of the 2 lithium ions will be working with its own BCDU. We're going through the update of our products right now to make sure that our different algorithms understand that we're running in a mixed configuration on this particular channel. And so those product updates are going to get across the finish line right about the same time that we finish these robotic operations. So that's all in work right now. So we understand what needs to happen in order to run in this mixed configuration, and those activities are in work within the ops community, ops and engineering communities.
Okay, thank you. And I had kind of a big picture question. The first 2 spacewalks, you were kind of at one general site, lots of big equipment. This time they seem to be moving around, more hand action, but I just wonder if you could sort of characterize the difference between this particular spacewalk once you're through with the batteries and working around the station as opposed to the battery swap out.
So for this spacewalk, we have a lot of unique work sites, and there's not a whole lot of opportunities to get access to those work sites in the future. And we have a number of future experiments that we are trying to prepare for. And the spacewalk that we're going to conduct Monday is a conglomeration of all those unique work sites that really didn't fit anywhere else. And so we're gonna tackle all of those tasks in one single spacewalk, as opposed to doing a number of shortened spacewalks with only going to one of those work sites.
Hi, Eric Berger with Ars Technica. I realize that things are always subject to change, but I just wonder if you could talk maybe a little bit about future EVAs that you would have planned for this calendar year, if any. I know April you've got the visiting vehicles and other things scheduled for later in the year, but I'm just wondering what other tasks are you hoping to accomplish outside the station this year?
Sure. We have a little later in the year, in the summer timeframe, we'll have the new docking assembly that's going to be coming up on one of the SpaceX flights, and that's going to drive an EVA there. Once you get past that, we really are wrestling with the numbers of EVA requirements between now and the end of the year. We have on the HTV 8 vehicle, there will be another external pallet coming up with a set of batteries destined for the outboard channel. And we know those particular EVAs are going to be longer, more difficult, in that there's going to be more of them. In addition to that, we're also considering the AMS repair sometime here before the end of the year. At least we're planning for it. We're working through all the details of hardware deliveries and procedure development and making sure that we can do it. But in terms of our thinking between now and the end of the year, those are 2 pretty major objectives that we're trying to work our way through. And do I think we're going to do all the EVAs for both of those objectives? Probably not, just because we got a lot of science between now and the end of the year that we're trying to get done with some of the vehicles that we have coming up. So I think we've just got to work through the rest of the plan, figure out what makes sense to do this year versus trying to get a more ready time frame to do those maybe sometime after the first of the year. So that's all still in a state of flux. We'll do the IDA here in the spring, and then we'll start to put a little more fidelity on the plan probably summertime when it comes to the spring, or when it comes to the fall and the winter.
Thank you, Mark Carreau from Aviation Week again. I'd like to follow up Eric's question and your comments on the IDA. Is there a requirement to have the second IDA installed as part of any of the qualifications for the commercial crew vehicles, or can you do all of that with one IDA?
Yeah, that's a good point. Yeah, just like we flew the first flight using the Node 2 forward, that's really what we need. but at some point in the future, we're going to want the Node 2 Zenith capability. Once we get up and running and start flying in a standard cadence, it's going to be to our advantage to do it. So, plus we like the redundancy in ports, to be quite frank with you. I mean, that's just, it's puts us in the best posture going forward. But in terms of a requirement for certification, no.
Thank you. And before we go to any questions on the phone, if you're watching and you don't know our acronyms, EVA is extravehicular activity, and that is a spacewalk itself. An IDA is an international docking adapter, and we also have the BCDU, the battery charge discharge unit. And John, if you would like to give us just a high-level definition of what that does and why it's important for the batteries.
So the BCDU, the battery charge discharge unit, it's what manages the batteries. So obviously, during the day we have big solar arrays, the power station, but during the nighttime the solar arrays are not drawing or generating power. So we've got the batteries, and the BCDU manages the state of charge of the batteries through that day-night cycle.
Great, thank you so much. We'll go to questions on the phone, starting out with Marcia Dunn with AP.
Hi, can you hear me?
We can.
Great. For Kenny, probably. Given the potential for greater numbers of women on the space station, will you be getting a second medium-sized suit ready in the near future in case the opportunity or need comes up again for a two-woman spacewalk?
Well, right now, Marcia, we don't have it in the work plan to go do that. If we find ourselves needing to get another medium, or one that one of our female spacewalkers needs another medium, and we need two of them, then we'll have to do some work on orbit to make that spacesuit available. We do have an upper torso, which is a medium size. It takes some amount of time to go do that, but yeah, we could absolutely do that if we found ourselves requiring that. If we had no other option than to go swap out the upper torsos, we can certainly go do that. Again, it's not something we do very often, and we take great care when we do it, and we want to make sure that when we have to do it, that we have the ample time to get it checked out.
Just one more follow-up along those lines. Why isn't there two medium-sized suits at the ready all the time? Is it a space issue on the space station where you just can't have so many suits all ready to go? Is it a lack of, I'm just trying to understand. I know it's a time issue to get one ready, but why not just have two mediums and two larges ready at all the time?
Well, again, I think a large part of that is due to reflected in the complement of the crew that we have on board, and what their requirements are. A lot of crew members, they can, what we say, upsize or downsize. They have a primary suit that they fit in, that they train in, but there's also some amount of training that's done in other size suits to see if those suits will work for them. And so that's just a standard way of doing business. And at some point in the future, if we deem that based on the crew complement that it's better to have things sized differently, then we'll certainly try to do that from a strategic standpoint.
And if I may, if I have one more question, is it just a timing issue for the last spacewalk, which should have been Ann and Christina? It wasn't merely you just didn't want to take the time, or were there other things going on, like it might have been posed a danger for the suits being put together at such late notice? I'm just trying to get a handle on how that all unfolded from your point of view.
Yeah, well, in general, we had a request from Ann on orbit directly from the crew member. We try to make decisions relative to all station ops with input from the crew. And in this instance, we had an input that said that we should go look at this and look at it carefully. That's what she made that request to the head of the astronaut corps. We all got together and talked about it and talked about the merits of the situation. And in the end, the decision was made that her recommendation to stay with Nick seemed solid. If there would have been a request to go change the HUD or try to resize to a medium, certainly that's something we would have gone and considered, but that wasn't the request. We looked at it hard to see what our options were. This was the second in a set of 3 EVAs. On the backside of this set of EVAs, we have 2 visiting vehicles. And to be quite frank, we're trying to keep as much margin as we can going into this 3rd EVA. You never can tell what's going to happen, and if you can keep the margin out in front of you, then just from an overall program management standpoint, it made better sense. So she offered a solution. We went and looked at it. We like the idea of trying to maintain the margin ahead of the 3rd EVA, and making sure that we're ready to support our visiting vehicles that are coming up shortly after the 3rd EVA. So anyway, when you look at the totality of the picture, and given that this particular recommendation came from her, we looked at it hard, and in the end accepted it.
All right, thank you. Next on the phone, we have Antonia with Florida Today.
Yes, hi, can you hear me?
Yes, thank you.
Great, thanks so much for taking my question. So regarding the spacesuits currently in use, will the space station see new EMUs before the program ends, and if so, when?
Well, in general, these spacesuits, they come up and down over a several-year period. The numbers that we keep on the station aren't going to change. But what we do is we cycle them up and down and put them through a refurbishment cycle. So that's an ongoing process that'll be going to the end of station.
And so, so NASA has no plans then to update then the current EMUs. So then the next time the new spacesuits comes would be for another mission, not for the ISS.
Well, certainly we are looking and working with the follow-on programs to make sure we understand what their requirements are. Space Station is a perfect test bed for these types of capabilities, specifically spacesuits, and so we're working again with the other programs and the EVA project office to try to look at the future and what is it going to take as we start to move further out into the solar system. So absolutely, we'll use Space Station as necessary to try to help prove out any new technologies associated with new spacesuits. And so we're absolutely a player in that. As far as having new suits for the station itself, I don't know of any plans. We've got our standard refurbishment plan for the existing spacesuits, and we'll continue to work with the other programs and as they seek to do their own technology developments in that area.
Thank you. And next up on the phone line, we have Hugo with the Canadian Press.
Thank you. Hi. I just wanted to know, there seems to be a lot of movement around the space station and a lot of little tasks to be done. I wanted to know, how long are they supposed to be out, and is it the average time of a spacewalk?
Yes, so the spacewalk is planned for 6 hours and 30 minutes in duration. That's the nominal timeline that we plan our spacewalks to. And so while it may seem like there's a number of unique tasks as part of this spacewalk, they all fit within the normal 6 hours and 30-minute timeline that we schedule.
All right, thanks.
All right. We'll take a couple of questions from social media, and if you are watching and following live, you can submit yours using the hashtag AskNASA.
Thanks. We have a question from Reich. He wants to know, how long does the life support resources in the spacesuit last?
Yep, so as Rick mentioned, the nominal spacewalk is 6.5 hours long, and we always try to keep a 30-minute reserve on top of that. So we always try to keep at least 7 hours in the suit. It does depend on how fast and hard the crew is working, though, but we try to keep at least 7 hours for an EVA.
All right, another question on Twitter from Nathan. What do you use to secure the cables to the space station? Cable ties, Velcro, bands?
So we actually utilize wire ties. They're metallic wire ties, so not the plastic cable ties you may use at home, but basically twisty ties, more like you kind of use on a bread bag. And so you actually twist those onto a handrail, lay the cable in, and twist it again, and that's what secures along the translation paths.
Thank you. We'll go back to the phone line now. We have a question from Megan with space.com.
Hey, can you hear me?
We've got you.
Great, thanks. Just a quick clarification. I was wondering if you could tell me how many hard upper torso units are each size are up there now, and then how many of each of those sizes are set up for spacewalks right now, just so I get the numbers straight.
Yeah. So we've got the, as far as configured for the spacewalk, we have a single medium spacesuit. We've got 2 large spacesuits, and we've got an extra large spacesuit. And then in terms of the spares, we have another medium spare, another extra large spare, and I think another large spare as well.
So we typically try to keep at least 2 of every size suit with the hard upper torso up there that we can change on and off the life support system as needed.
Great, thank you.
And another question on the line from Sean with Spaceflight Insider.
Yes, good afternoon. The question about timing for the EVA was 6 hours, 30 minutes. I'm wondering, can you speak to how much time is required specifically for the battery work, which was ahead of the work you described for the what was originally planned for EVA 3?
Sure. The battery tasks that we have added to this timeline are 1 hour and 30 minutes in duration. Those will be the first tasks that the crew members will execute once they come outside of the airlock. And to accommodate the 1 hour and 30 minutes that we added to this timeline, there were other tasks that were lower priority that we had to defer to a future spacewalk.
Thank you. Follow-up question. If you did make reference to keeping the margin out in front, if there are developments or things off nominal about this work and it requires a 4th EVA, do you have any capacity to execute that before the 2 vehicles arrive later this month?
I think that will depend on exactly the nature of the issue. If we run into a significant problem and it takes our engineering and ops team a little extra time to try to figure it out, we'll buy ourselves some time. But I think at this point, yeah, we just have to see what kind of problem we're dealing with. You know, we have the ability to go out on pretty short order, especially when the situation where we're in right now. We do get some efficiencies from a spacewalk standpoint by putting them together like we have here. So if there was something immediate that we had to turn around and go back out the hatch for, and it was that critical, then sure, we could try to do it. And at the end of the day, you know, we can move a vehicle to the right if we have to, if we're looking at trying to save the station or recover some capability or something like that. But in general, a lot of it's going to depend on exactly what type of issue that we're dealing with.
Okay, I think we have another question on social media using the hashtag #AskNASA.
All right, Amin is wondering, what are the risks for this kind of EVA?
So anytime we send the astronauts out to conduct an EVA, there's a risk associated with performing those operations. There's nothing unique that the crew members have not been exposed to as far as training on the ground. Both of our crew members, Anne and David, have had opportunities to perform tasks similar to these while training at the Neutral Buoyancy Laboratory, which is our pool that we use to conduct our spacewalk training. And so we're highly confident in their abilities to execute the tasks on this spacewalk.
Another question on Twitter that is somewhat related. In case of need, how much the repress time of the airlock can be accelerated in order to have the spacewalkers back inside?
In a true emergency, if it's a life-threatening event, I mean, the airlock can be repressed in under 2 minutes. So it's a lot faster than we normally would. There are other implications to doing so, but if it's truly life-threatening, you can do it in under 2 minutes.
Great, thanks. Do we have any more questions in the room?
Just to follow up on the potential AMS spacewalk later this year, when I had talked to him a couple years, Sam Ting mentioned that there would be 4 pumps potentially sent up to station. Is that maybe the hardware you were talking about needing to go up? And what is the status of the cooling system? I think they were down to 2 cooling pumps, one of which was kind of a little flaky. So maybe you could just talk a little bit about the configuration of that instrument now.
Okay. Yes, with regard to the current condition of the AMS, I really would have to tell you to go talk to the AMS project folks. They're continuing to monitor their pump situation. 2 pumps, and they're continuing to evaluate. As far as the EVAs go, yes, they're building a pump package. They're going to deliver that to space station. In addition to that, we have a pretty good number of AMS-specific tools, EVA tools, that have been developed to support some of the tasks here that are just tasks that quite frankly, we just haven't done before. And so they've developed some unique tools, and getting those tools delivered is part of the picture as well. So anyway, those will be hitting the dock here hopefully in the next few months.
And could you maybe just talk a little bit about, because my understanding is that a lot of work has gone into preparing for this fix, in terms of astronaut training time and the special tools you mentioned and the pumps and so forth. Could you just maybe talk philosophically a little bit about how it's important for station to facilitate this kind of research, or why maybe the program has put so much effort into this?
Well, there's a couple of years ago, I was at a payload ops integration group meeting where we were getting ready for a future increment, and a lot of the new customers that were there, I was trying to give them a feel for how we as the space station community are really wanting to support the science community, and I brought up this particular AMS payload as being one that, quite frankly, they're threatening to rewrite our physics books. And we as a space station community, as a NASA community, this is something that is near and dear to our heart. And so the research that Dr. Ting is doing and his team, and the collaboration, they are very much on the verge of changing the way we think when it comes to particle physics. And so there's a lot of interest in making sure that we continue to collect data and continue to see if we can push our knowledge further when it comes to these type of physics. It's very impressive what that group is doing. So yes, we're spending a lot of effort, we're spending a lot of time to try to do it, but again, in the end, we think it's worth it, and it's certainly something that NASA supports.
Thank you. Okay.
I'm Mark Carreau with Aviation Week in Space Technology, and I think this is for Kenny Todd. Looking at the spacesuits you have now, what's your sort of sense about their utility through 2024 and possibly longer? Can you get there? I think that's my bottom line question with what you got and the kind of work that you do to maintain them on the ground and in orbit.
Sure. I would tell you several years ago, we went through what I thought was a pretty significant learning curve after shuttle retired, and we had suits on orbit, and we were doing things on orbit that typically were done on the ground relative to maintenance. And I think we learned some things along the way there. The maintenance activities that we have in play right now on space station, I think are about as good as we can get. We understand the situation with water and how to make sure that we don't let water get in places it shouldn't. And I think through the repetition of cleaning suits and taking care of them over this period of years and months, we've seen that the suits are pretty much solid in terms of being ready to go when asked. And so no concerns there. As far as the longevity and what we can expect throughout the program, as long as we're able to continue over certain periods returning these things to the ground, we feel pretty good about our ability to take care of them on orbit and then do the refurbishment at the proper time interval. So I think that we've shown pretty good success in that area. So I don't see anything You know, I'd have to go talk to the folks that are a little closer to that and understand their sparing situation during refurbishments and all that to see if all that equipment's in place. But I certainly have heard of nothing, Mark, that would tell me that we couldn't continue down this path for a very long time.
We're going to go back to the phone. We have another question from Sean with Spaceflight Insider.
Thank you, Sean Costello. Question, during the video, the summary video, there was reference to some wireless Ethernet capability being installed. I'm wondering, can you speak to any tests that might be performed on orbit or while the EVA is underway in order to validate that that work is done? And second part, what vehicle might first be expected to make use of that wireless Ethernet capability?
So we have the task in our spacewalk coming up on Monday sets the groundwork for the future expansion capability. So we have a cable that we're going to install on Monday that actually has about 8 connections, and that's why we colloquially refer to it as a spider cable. There's 8 special connections that we can then hook up in the future, and we can provide the wireless capability throughout the space station. And as new payloads fly on board and require more and more data throughput, having that wireless expansion capability to support their needs is a crucial element of enabling the success of the space station.
Thank you.
We have another question on the phone from Christine with CBC News.
Hi there, can you hear me?
We've got you loud and clear.
Perfect. Jumping back to accommodating for the battery tasks, what tasks were deferred to future spacewalks to allow for this?
So the tasks that we deferred it's actually related to the Ethernet cable that we are going to route from the lab back to the truss. We were going to use one of those 8 connectors that I referred to earlier, and we were going to mate an Ethernet cable and run it out to the starboard portion of the truss. And it takes a long time to do all the wire ties that John mentioned earlier. And so the duration of the task to route the Ethernet cable out starboard was the one that we were going to have to defer.
Great, thanks so much.
And we have Marcia with AP on the phone as well.
Yes, can you hear me again?
We can, thank you.
Yes, Kenny, yesterday Jim Bridenstine said that there was increased risk of debris because of the Indian satellite that was destroyed in the test. I'm wondering if you're taking any special precautions to monitor debris in light of this, and does this extra debris up there pose any extra risks for spacewalkers?
In general, Marcia, there's a lot of debris on orbit. There are folks out there who track that debris. So when the event first happened, certainly caught us by surprise. We were coming up on a spacewalk. We looked at it very hard to see if there was any increased risk. We got our specialist, our trajectory specialist that worked with the teams identifying where the objects were. And at the end of all those conversations and the analysis, it was a very minimal increase in risk to send our spacewalkers out, and so we decided to. Over time, this particular threat died down pretty quick. There are some objects that are still up there. Those are cataloged, and every event that comes up, including the spacewalks, the upcoming visiting vehicles, there's a screening process that occurs in looking at where we know the debris is, not just this debris, but all debris on orbit, and screens to make sure that the trajectory, including the ISS trajectory, aren't on a collision course. And if so, then we get together and talk about what our options are, including doing a height adjustment burn on station and or just waiting and letting it pass. So that's an ongoing process. We're past the early parts of that concern, and now we're basically just monitoring and tracking it, just like we all do all the other debris.
All right, thanks.
Do we have any final questions in the room? Okay. Well, that's all the questions we have today. Thank you all for joining us live and online. We hope that you'll join us Monday, April the 8th for the Spacewalk coverage. That'll begin at 5:30 a.m. Central Time, and you can also follow along on the space station's social media accounts. That's on Twitter at space_station, facebook.com/ISS, and on Instagram at ISS. Thank you again. And thank you to our guests for joining us today. We'll see you Monday.